Hello, today we will be discussing the geological distribution of the Pelecypods. Pelecypods can also be called as lamellibranchs or bivalves. That means the terms Pelecypods, lamellibranchs and bivalves, if they are used in alternation, it means the same group of animals. All the lamellibranchs are aquatic animals. That means they are something which are usually not found on the terrestrial ecosystems, and by far the larger number are marine. The marine forms range from the shoreline down to a depth of 2,900 fathoms. What is a fathom? Fathom is basically a distance depth where 1 fathom equals to 6 feet or 1.8 meters approximately. They are mostly abundant in shallow water and are scarce at depths greater than 500 fathoms. That means, in the depths more than 500 fathoms, these populations they decline, populations of lamellibranchs they decline, but the following and a few other genera have been found below 1500 fathoms like Nucula, Nuculana, Arca, Lymphosis, Malacia, Verticordia, Cuspidaria, etc. Two genera which may be lamellibranchs have been recorded from the lower Cambrian of North America. In England, the earliest forms appear in the lower Ordovician. Lamellibranchs are not usually common in the Ordovician, but the Taxodonta, Metalaceae, Terriaceae and Paleoconcha are represented. These groups continue throughout the Paleozoic. The Paleoconcha being especially characteristics of the Ordovician, Silurian and Devonian. The schizodonts are well represented in the Carboniferous and Permian by the Schizodus, Carbonicola, etc. The Pectinaceae begin in the Silurian and become numerous in the Upper Paleozoic. In the Carboniferous, the Paleoconcha are represented by Admondia and Sanguinolitis. Alorsima, Carboniferous and Permian is the time that can be attributed to these forms, is one of the Paleozoic genera with a pallial sinus. What is pallial sinus? Pallial sinus is a morphological features which is identified by a notch into the pallial line. Lamellibranchs form an important part of the faunas of the Mesozoic and Tertiary formations. Most of the Paleozoic genera die out before the beginning of the Mesozoic. In the Triassic, the Terriaceae, Pectinaceae and Metalaceae are abundant. The Ostraceae and Anomaceae now appear. The Schizodonta, Heterodonta and the Desmodonta are represented by a few genera in the Jurassic and Cretaceous. All these groups increase in importance. The Taxodonta are represented by numerous forms allied to Arca and Cuculaceae, the Schizodonta by many species of Trigonia. The Cretaceous period is distinguished by the abundance of the Inoceramus and by the presence of the rudistid bivalves. What are rudistid bivalves? The rudistid bivalves are the bivalves which are represented by Hippuritis, Radiolitis and others. In the Tertiary period, the heterodont group attains the greatest importance. Freshwater lamellibranchs are generally rare in the Paleozoic and Mesozoic formations. Probably the earliest forms or Archanodon or Amnigenia Jucaceae forms the old red sandstones. That means, most of the old red sandstone formations they are characterized by these lamellibranchs. In the coal measures, several species of the Carbonicola, Anthracomya, and naiaditis occur. The living type Unio has been found in the inferior oolite of Yorkshire, and the Unio is also found in many of the Indian rocks as well, and is fairly common into the Pubecian and Wealden of the south of England, where it is associated with Sirena. Freshwater lamellibranchs also occur in the Woolwich beds, the Oligocene deposits, and in the Pleistocene river gravels. Now, let us talk about their evolution. Bivalves are generally thought to have evolved from the extinct molluscan class Rostroconchia, although this is not universally accepted. The first fossils widely accepted, but again not universally as bivalves, are from early Cambrian rocks. Fordilla troyensis is known from a large number of specimens from the Tomosian localities in North America, Greenland and Western Europe, while Pogeteia runengari is known from Australia. Both Fordilla and Pogeteia are small, only a few millimeters in length, and are generally thought to have been shallow burrowers. Despite this early appearance, there is then a gap in the bivalvia fossil record throughout the middle and upper Cambrian before their reappearance in the early Ordovician or Tremadoc. This gap is both perplexing and frustrating also, because it spans something like 4% of the evolutionary history of the class and covers an interval when bivalves apparently become larger and more diverse in terms of both taxa and the life habits employed. There have been several claims for the middle and upper Cambrian bivalves, but most of these have been dismissed, and they are thought to be as misidentified inarticulate brachiopods. It is difficult to explain this gap in the bivalve record, but one plausible explanation is that the earliest bivalves may have lived in near-shore silty facies, which are seldom preserved. By the close of the Ordovician, bivalves were more common and abundant, and all these subclasses recognized had appeared. There is evidence of shallow burrowers and both endo and epibisate forms, and signs of different feeding strategies, that is deposit feeders, suspension feeders, etc. Bivalve diversity continued to increase throughout the Paleozoic, although there are small decreases associated with the Ordovician and the Devonian, that is Frasnian Femminian mass extinctions. Throughout the era, most bivalves remained in the primitive life habit, with only one genus, each of the borers or Coralliodomus and the cementers, that is Pseudomontis, being recognized, and neither of which is widespread. Very few Paleozoic bivalves like Lyrodesma have pallial sinuses, although the effect of the end Permian mass extinction is clearly evident. Losses were small in contrast with those sustained by the other shelly benthos, for example, the brachiopods. The beginning of the Mesozoic saw a further combined increase in the number of taxa, with an ever increasing repertoire of life habits. Many shallow burrowers moved deeper, and large number of bisate taxa adopted more specialized habits such as cementing, boring and free living. The cementing habit is exemplified by the successful oysters and rodistids. The first evidence of the adaptations for swimming in scallops is recognized in Jurassic taxa, and free reclining Graphiid oysters became abundant and widespread in this period. This major adaptive radiation is widely thought to have been linked to the Mesozoic marine evolution. The profound restructuring of the shallow marine communities, and in particular a massive increase in predation pressure at that time. Bivalves are extremely vulnerable to predators and are attacked by a wide range of important predatory groups. Like for example, if you see the fossil bivalves of the recent shells, you will find some holes or circular punctures onto their shells. These punctures might be, I do not say that you must identify or recognize all the punctures like that, but if you see any rounded, well rounded punctures on a shell of a lamellibranch, it may be that some predator or attacker might have punctured the valve and sucked the soft parts. And the important predators might include fishes, gastropods, starfishes, crustaceans, mammals and even birds, and by a variety of different methods like swallowing whole, crushing and drilling apart. It has been suggested that different groups of bivalves responded in a variety of different ways. For example, by living deeper within the sediment, encasing themselves in hard substrates and becoming more robust, and in some cases growing formidable spines. So, these are the habits which the lamellibranchs acquired in order to protect themselves. Although the end Cretaceous extinctions had a marked effect on the bivalves, with major groups such as the inoceramids and rudistids being completely lost for no time to come back. Their diversity continued to increase during the Cenozoic. The number of groups exploiting the boring and cementing habit has continued to grow, and there has been a further taxonomic explosion of the shallow burrowers at lower taxonomic levels. We have learned the geological distribution of lamellibranchs today. We will learn the geological distribution of the other groups in the other lectures or the coming lectures to come. Till then, thank you very much.